Hey there, today we're looking at how to multiply and divide rational expressions. You can see an example of this on the screen right now, so if you're not familiar with how to do an operation like this, then stick around and we will learn how to do it. Let's get started then. So first we're going to talk about multiplication. Okay, so if you know how to multiply fractions, then you know how to multiply rational expressions. Okay, so here's sort of just the general rule for fraction multiplication. You can just sort of imagining extending that fraction line across both of these, and you get your result here, right? So a over b times c over d will equal ac over bd. So let's do an example here. Let's say we have a number like, I don't know, 1/2, and we multiply this by a number like 4/5. What are we going to get? Well, just combine this together. We're going to get 1 times 4 over 2 times 5, right? That's it. And this is going to be then 4 over 10, okay? However, we can actually simplify first, can't we? We can see that over here, this 2 and this 4 are going to cancel out. It's going to leave a 2 over here. And so we can see this is the same as 2/5, okay? So that's probably a better way to solve this problem. But of course, if you multiply top and bottom by 2, you will get 2/5 times 2 over 2. That does equal 4/10, right? So that is the original number that we would get if we didn't simplify, but generally speaking, it's better to simplify and get a more concise result there for our multiplication. That's the idea. Okay, now rational expressions are essentially fractions, but instead of made of numbers, they're made of polynomials. So let's look at an example like this one. Here we're multiplying two rational expressions. So each one is a fraction that is created by a polynomial on the top and on the bottom. So we can do the exact same thing for this, right? What we can do is we can say this must be equal to 3x squared multiplied by x plus 2 all divided by x squared minus 4 times 9x, right? You just multiply the numerators, multiply the denominators. And essentially, we're done, but we should try and simplify, right? So how do we simplify here? Well, we can do a few things. First of all, we can notice that this 3, let's do that in red, this 3 will cancel with this 9, leaving a 3 here. And then one of these x's will cancel out, so we'll have x to the first power, right? So I can sort of simplify this a little bit. Let me say that this is then going to equal x times x plus 2 divided by x squared minus 4 times 3. Okay, so I've simplified a little bit, but I think you can see we can simplify further. This x squared minus 4, that's the difference of two squares, isn't it? Right? So I can rewrite this as, well, in the numerator, I still have this x times x plus 2, but in the denominator now, x squared minus 4 is going to be the same as x plus 2 times x minus 2, and all of that is still multiplied by 3. And so finally, we see we can then cancel out this x plus 2, thus giving us our final result of x divided by x minus 2 times 3. All right, so there we go. That's going to be our simplified form of what we get here when we multiply these two rational expressions together. Let's take a look at another example. Okay, we have two rational expressions here we're trying to multiply together. We notice, though, that we can actually simplify right off the bat because we have an x minus 3 here and an x minus 3 here. So if we're just multiplying these, you can actually cancel those out. So let's do that. Let's cancel out these two x plus 3's. And now let's write down our simplified versions. That'll be an x minus 9 over an x squared plus a 6x plus a 9, okay? Technically, this is the result, but we can simplify further, can't we? So if we look at this this numerator, this will be an x squared minus a 3 squared. That's a difference of two squares. We know that's going to give us some x plus 3 times an x minus 3, okay? So we can factor out that numerator. And the denominator we can also factor. You might recognize this as a perfect square trinomial pattern. What that means is I can think of this as an x squared plus a 2 times a 3x plus a 3 squared, right? And this is the pattern for a perfect square trinomial where the factor here is going to be x plus 3 quantity squared. So let's write that down. let's grab this section here. And this is all going to be over an x plus 3 quantity squared. From here, we can cancel this x plus 3 with one of these, giving us our final simplified result of x minus 3 over an x plus 3. And there we go. Okay, not too bad. So that's our final simplified result after multiplying these two rational expressions together. We can also try and remember the domain. Okay, so it's useful to try and remember what the domain is going to be. So if we look at this this rational expression here, we see we have an x plus 3 in the denominator. Technically, it was squared, and actually, there was another x plus 3 in the denominator from the beginning. So it's kind of like an x plus 3 cubed if you go all the way back to the original expression. So that's telling us that x plus 3 cannot equal 0, which means that x cannot equal negative 3, right? Just subtract 3 to both sides. So that's going to be the only real restriction on our domain. The domain will be any x such that x is not equal to negative 3. Okay, and there you go. Try and remember the domain here. Let's take a look at division next. All right, so here we have division, and just like multiplication, if you know how to divide fractions, you know how to divide rational expressions. So how do we divide fractions? Well, you take the second one and you take the reciprocal of it, you flip that over, and then you just do multiplication, right? So that's the rule here for fraction division. We're going to apply that to rational expressions. First, let's look at an example just using numbers for our fractions here. So for example, let's say we have a 2/3 and we're going to divide this by a 1/3. What's that going to equal? Well, we can take this second fraction, get the reciprocal of it, and then multiply. So that'll be a 2/3 multiplied by a 3/1. Notice these 3's will cancel out, and so we're just left with 2/1, which is just 2. Okay, there we go. Nice and easy. This is how we can divide numbers. You could have also written this problem here as a kind of 2/3 divided by a 1/3 like this, a kind of more complex fraction. You would get the same result, right? So to take this out of the denominator, you'd have to bring it up and get the reciprocal. So you would get this step next, be the exact same answer. Okay, so let's take a look at a problem here involving a rational expression. How about this one right here? Okay, so what do we have? We have x squared minus 9. We've got an x squared plus 3x divided by x minus 3 over x. I'm going to transform this into multiplication. That's what we want to do here. We want to change this into x squared minus 9 over x squared plus 3x multiplied by x over x minus 3. Now that it's multiplication, we know how to do this, and it's not too bad. So we can try and multiply everything together and then simplify it. So if we multiply everything together, we'll get an x multiplied by an x squared minus 9 in the numerator, and then in the denominator we have an x squared plus 3x all multiplied by an x minus 3. Okay, so that's what we get next. We're kind of done, but we can simplify. Okay, so let's try and simplify here. This top part here, this x squared minus 9, we recognize that as a difference of two squares again. So we can simplify this down to x times an x plus 3 times an x minus 3. And then in the denominator, this part's already simplified, but this one we can factor out an x, right? So we can factor out an x from both of these terms. That'll give us an x times an x plus 3. And then we have the x minus 3 remaining. Well, look at that. Everything cancels, and we're just left with a 1. Okay, so there we go. Turns out that this mess that we started with, when you divide these two together, you actually just get 1. So that's a kind of a nice result. Let's try another example here. All right, for our final example here, we have two rational expressions. I'm going to try and just factor both of them out so we can sort of see what's going on. So for example, for this first one, the bottom I see is a difference of two squares, but the top, that might be a little bit more interesting. So let's try and factor this polynomial on the top first. Factoring quadratic like this, we're looking for the factors of 3 that add together to give us -4, right? The factors of 3 that add together to give us -4. Well, what's that going to be? I think that's going to be a -1 and a -3, right? If I multiply these together, I get 3, but if I add them together, I get -4. Okay, so this is what we're going to use here for the factors on the top. So essentially that means we can factor this into some x minus 1 multiplied by an x minus 3. And then in the denominator, this x squared minus 9, that difference of two squares, is going to become an x plus 3. Let me write that a little better. Multiplied by an x minus 3. Okay, so I've rewritten this first rational expression into this new form just by factoring it out. I'm going to leave that for now. Let's look at the second side here. Okay, so for this second side, we want to do the same thing. Now, to factor the top, I need to find the factors of 6 that add together to give me a -5. So the factors of 6 that sum to give me a -5, right? That's what I'm looking for here. The factors of 6 that sum to give me a -5. And I think that's going to be a -2 and a -3. Right? So if I multiply these together, I get +6, and if I add them together, I will get a -5. Okay, so that's what we have here. Now for the next one here looks like we find the factors of -6 that sum to give me a -1. All right, let's write that down. So the factors of -6 that sum to give a -1. What's that going to be? I believe this is going to be a -3 and a +2, right? So if I multiply these, I get a -6, but if I sum them together, I get a -1. Okay, so that's going to be what we get over here. So that means I can rewrite this entire rational expression. In the numerator, I will use these factors here. I will get an x minus 2 times an x minus 3. And in the denominator, I'll use these factors. I'll have an x minus 3 and an x plus 2. Okay, so there we go. That's going to be rewriting both of these rational expressions just by factoring everything out. Now, to divide them, what I have to do is I'm going to take this expression right here, and I'm going to multiply it by the reciprocal of this one. Remember, I have to flip that over. So in the numerator, then, we're actually going to get the x minus 3 times x plus 2, and in the denominator, we will get this x minus 2 times x minus 3. Okay, so this is how we create a multiplication. Multiplication's simple. We just multiply the numerators, multiply the denominators, but we can actually cancel a lot of things now, can't we? So let's see, what can we cancel? Well, this x minus 3 and x minus 3 cancel. This x minus 3 and this x minus 3 also cancel. And I think that's everything that cancels. Okay, so our final result will be x minus 1 times x plus 2 divided by x plus 3 times an x minus 2. And there we go. Okay, that's going to be the final result after we do this division of these two rational expressions here. Let's think about the domain. Okay, let's not forget the domain. So for the domain, what's this going to be? Well, we can see here this x plus 3 means that x cannot equal -3, right? So it's going to be any x such that, well, so we have a -3 here that x cannot be -3. That would give us a 0 in the denominator. Here, x cannot be +2. That would give us a 0 in the denominator. But in addition to that, so we've got a -3, we've got a +2. In addition, notice that although we canceled out these x minus 3s, they're still there in the original expression, right? There's still an x minus 3 that we get from here and from here. And so that is technically still in the denominator. So we want to make sure that x is also not equal to +3, right? +3 would also give us a problem. That would give us a 0 here. And so these are the three values that we want to make sure x is not, right? X cannot be any of these. So we'll just add that into our set builder notation. So we'll say the domain is any x such that x is, well, there's many ways to write this. You could just list them out. I'm going to say x is not an element of the set 2, 3, and -3, right? So that's the idea. This is going to be the domain of our rational expression here after we do this division. Okay, so there we go. That's how we can multiply and divide rational expressions. It's just like multiplying and dividing fractions. Okay, so if you're good at that, this shouldn't be a problem. You just have to maybe simplify afterwards to get a more concise result. See you next time when we learn how to add and subtract rational expressions.